Okay, so this is Ms. Leva, and this is part 2 of our video for scale models and scale drawings. So on the first video, we did focus more on the drawing side and basically on the map side of it all. So we're going to go ahead and move into some more real-life examples using scale models and scale drawings. So example number 3, Ethan made a scale model of a building. The scale model is 37 centimeters tall, and the actual building is 222 meters long. So what is the scale that Ethan used for the scale model? So if you notice here on the maps, they usually gave us the scale that was used in order to make the measurements either bigger or smaller. Here, I need to basically work backwards to try to figure out what is the scale that Ethan used to create this model building. So just like with my other examples, I am going to be setting up a proportion with my 4 labels in order to figure out what is the scale that Ethan used. So if I look at the scale, it kind of already set up some labels for me. I have centimeters on the left side and meters on the right side. So I'm going to stick with those as my labels. Centimeters here, meters here. I know that I'm doing a proportion, so I'm going to make those into my ratios. And then for my other labels on the left-hand side, I'm going to use the scale because that's what I'm trying to find here. And I'm going to use the building for the other label because I'm talking about a scale model of a building. So for my scale, I know I'm going to have 1 centimeter. I still don't know how many meters that's going to be, so I'm going to just use the variable x again to represent my missing number. For the building though, the building does have some centimeters. The scale model is 37 centimeters, so I can put that here under my centimeters label, keeping all my centimeters together. And then the next thing I know is that the building is 222 meters long, so I can put that under my meters label for the building. 222 meters for the building. And so now I need to try to work out this proportion, and remember there is several different ways you can solve proportions. For this one though, I think I'm going to work with 37 going up to the number 1. So if I was to work from 37 up to the number 1, I'm getting smaller, so I know I have to divide by something. So I know that any number divided by itself equals 1. So I'm actually dividing by 37 here. So 37 divided by 37 gives me the 1 on the left hand side. So remember with your proportions, whatever you do to the left side, you must also do it to the right side. So I also need to divide by 37 on the right side. So in order for me to find out how many meters are in the scale that Ethan used, I just need to divide 222 divided by 37. So 37 will go on the outside, 222 will go on the inside. I'm going to go ahead and try 37 times 6. That's 2, that's 4, that's 18, that's 22. So it looks like it will go in there 6 times, and I don't have a remainder. So my x value that I'm looking for is equal to 6 meters. So the scale that Ethan used in order to create this model was that 1 centimeter is equivalent to 6 meters. And so again, here I was working backwards to try to figure out what scale he used, but I still use the proportion with my 4 labels. Moving on to our next example, number 4. So here we have a scale drawing. So remember again, this is kind of like what architects use for blueprints and so forth. So in the scale drawing above, each square represents 1.5 feet. Find the actual length of the height of the house, the height of the windows, the height of the roof, and the dimensions of the door. So for example 4, because I'm given this information up here about each square representing 1.5, that's basically the same thing that we've been doing with our similar figures as far as our scale factor. So remember, our scale factor is the number that we use to make the shapes either bigger or smaller. So I'm going to think of this basically as a scale factor, and I'm going to use that to find the dimensions and the measurements that I'm looking for here. So starting off with the height of the house, so what I would do is I would first count how many squares the entire height of the house is. So starting from the center of the house, coming all the way down, so from the top of the roof straight down the middle. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So there's basically 22 squares. So 1 square is equivalent to 1.5 feet. So 22 squares is equivalent to how many feet? So again, I'm basically solving a proportion. So I'm going to go from 1 down to 22 by doing times 22. So I would do the same thing to the right side of my proportion. Again, I would do 1.5 times 22. And I'm going to go ahead and just use the calculator to save us a little bit of time. So 1.5 times 22 equals 33 feet. So it looks like the height of the house, the entire house, is 33 feet tall. So I'm going to go ahead and move into example number 2, the height of the windows. I want to know how tall the windows are going to be. So I'm going to do it the same way. I'm just going to count how many squares the window is. So 1, 2, and 3. And so basically I am going to multiply that. Let's set up our proportion. 1 square equals 1.5 feet. And I have 3 squares here. So from 1 to 3, I multiplied by 3. So I do the same thing on the other side. I also multiply by 3. If you want to use your calculator, if you don't know what that is, 1.5 times 3 equals 4.5 feet. So 4.5 feet. So it looks like the height of the windows is 4.5 feet tall. Next one, the height of the roof. So now I'm only looking at the roof. So I'm going to count the squares there. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So another thing I can do is use, again, this number, this 1.5, I can use that as a scale factor like I did with my similar figures. So basically I would just take the dimensions of the roof right now, which was 10, and I would multiply it by the scale factor of 1.5. So 10 times 1.5 is going to give me 15 feet. So the roof is 15 feet tall. So you do have 2 different ways that you can solve this out. The first one being with a proportion, and then the other one would be using the square representation, using that as a scale factor like we did with our similar figures. And then lastly, the dimensions of our door. So 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4. So for the height of the door, it was 6 squares. So I would do 6 times 1.5. Again, if you don't know what that is, you can put it into your calculator. That's going to give me 9 feet. And then the width of the door is 4 squares times 1.5, which is 6 feet. So the dimensions of the door are 9 feet by 6 feet. These are the 2 measurements for the door. It's 9 feet tall and 6 feet wide. And then our last example, find the length and the width of the actual room that is shown in the blueprint below. So again, this is just a drawing of what should be a bedroom or a room somewhere. And we have a scale that's actually given to us on the drawing. So this section right here is representing your scale. So this is the scale that we're going to be using to find the measurements of the actual room. So for this example, I will be setting up my proportions again. So I'm going to use my labels. I've got scale, I've got the room, and then I have inches, and I have feet. And I'm going to go ahead and put in whatever numbers I know for this proportion. So for my scale, how many inches are in my scale? So I come over here and I see that there is 3 inches in the scale. What about the room? So I'm going to work with this side of the room first, which is 6.5 inches. Again, I'm keeping all my inches together right here coming down. Now for my scale, what about my feet for my scale? It's 8 feet. And then for my room, I need to figure out how many feet that is. So this is going to be my X value right here. So I need to look at this proportion and try to figure out how I can work with the numbers that are here. So either how can I get from 3 to 8 or from 3 to 6.5. So let's see what's going to be the easiest way for me to work with these numbers. So it looks like I'm going to get repeating decimals no matter which way I work with these numbers. So I'm going to go from 8 to 3. So to get across, again, if you don't know how to get across, you can always take those 2 values and divide them with each other. So 8 divided by 3, if you put that in your calculator, is going to be 2.6 with a repeating 6. So what that means is that I'm getting across by multiplying by 2.6. And again, this is going to be an estimate because it does have that repeating decimal. But remember, with your proportions, whatever you do to the top, you must also do it to the bottom. So I'm going to do 6.5 times 2.6, which is going to give me approximately 16.9 feet. So the longer side of the room should be about 16.9 feet. And again, this is just an estimate because of the repeating decimal that we had there. So we have one more dimension for the bedroom that we're looking at. So we're going to set up one more proportion. Again, we have our inches on one side, our feet on the other side. And we're going to use scale again. And the room again. So in my scale, I have 3 inches. And I also have 8 feet. And then the other measurement I have is the 5 inches for the room. So I'm going to put the 5 inches underneath my inches label. This will be my X value that I'm looking for. I'm trying to find the feet for that room. And because I do have the same scale, I'm going to go ahead and use the same method to solve my proportion. I'm going to go across by doing times 2.6. Remember, whatever you do to the top, you also do it to the bottom. So to get my bottom measurement, I'm going to do 5 times 2.6, which equals to 13 feet. So remember, this is an estimate because of the repeating decimal, but that other side of the room should be about 13 feet.